Standing waves are waves that appear to be standing still, which means it doesn't look like they're moving. When you're doing jump rope, you have a standing wave, it looks like it's standing still. On a standing wave, this will be really, really key when we talk about instruments and things. You always have a node at the end. You'll always have one at each end. Okay? Okay, so you'll have a node here, and you'll have a node here. If you have a standing wave with a higher frequency, you're going to have a node here, a node here, a node here, and a node here. And those are the places where the wave is not moving. Okay, but your wave is basically just flip-flopping back and forth. And I'll show you guys how to do it. It's really neat. And you can make them with this greater frequency. That means you're moving it faster. So all of these things in pink are the nodes. The faster you go, the more nodes and more antinodes you're going to get. But you're always going to have at least two because you've got one at each end. Now let's try a different color. Your antinode is here and here. But we call that one antinode because it's like just the same thing. It's just oscillating back and forth. Then you have an antinode here, here, and here. You can see your nodes, you'll always have one at each end. Where your antinodes, you'll always have one less than your antinodes. So if your node is equal to n, then the number of antinodes will always be equal to the number of your nodes minus 1. Okay, you can see we have 2 nodes, 1 antinode. 4 nodes, 3 antinodes. We have 5 nodes, we'll have 4 antinodes. I've seen problems that say like, if a wave has 6 nodes, how many antinodes is it going to have? Or if a wave has 6 antinodes, how many nodes is it going to have? So, so you may see things like that, and this will be really, really key again when we start talking about sound. So make sure you know these standing waves and the difference between a node and an antinode. Resonance. This we're going to talk about more and more and more when we talk about sound. This is just like a baby introduction to resonance. And again, you can see all these standing waves that are here. I really like this picture because you can see as you increase the frequency, they get smaller and smaller, these wavelengths. So this is just a special form of this repetitive motion that occurs when small forces are applied at regular intervals. You guys will do this in class. It'll be really, really fun. You'll have, it's kind of like jumping rope, but not exactly. You have this spring, and you guys will both shake it. It's kind of like one eye. Let me get another. You'll shake it, and you'll get that same. It'll go like this, and then it'll switch back like this, and then it'll go like this, and it'll switch back like this. If you increase the frequency, you shake it faster, you're gonna get it going like this, then it'll go like this, and the faster and faster you shake it, you can see this one right here in the middle. It has a really small wavelength but a large frequency, and this one has a larger wavelength but a shorter frequency.